Hello again. So last time we left when we finally created our terrain, as you can see here, and now we're going to create a forest on top of it. Okay, so because we don't want anything about this point to cook every time we open Houdini, just drop in a file cache node and and create the file. But now I realized that I didn't add the necessary nodes before converting it. So now we need to go in and again create the scatter nodes, height field scatter, because we want to use the height field masks to drive our scattering. So I'm gonna hook it up and just wait because it needs to cook, and it's cooking now. And we'll wait a bit more while this is cooking. The way we're going to handle the forest is we're going to scatter a lot of points, and we're going to use an L system to create our trees. And after we have our trees, we're going to write them to disk, 60 or 50 variations of it, and then we're going to use disk-based instancing to instance them back onto the points at render time. And this is going to be the most efficient instancing that we can possibly use for this scenario, because a lot of times we're going to have the points not inside the camera when we set up our cameras and animation, and that's why we can this way Mantra will optimize its memory usage, not load the points that are not inside the frustum. Sorry, not load the instances that are not inside the frustum. It's basically going to save a lot of memory. I'm sorry, I'm a little bit sick, so my voice is a bit like this. Okay, so now this is finished. So this is gonna scatter a lot of points. So we're gonna put here 2, maybe, yeah, 2 or 3. We can change after. Okay, max points. So because we can use, because this is not a detailed terrain creation tool tutorial, but the height field gives us bedrock, debris, all these information, basically, which we can use for, like, if you have a river, you know, you don't have to worry about the you don't have to worry about how if there are trees inside the river or not, because you can use these masks to create your scatter mask. Is much more advanced. But now we're going to leave it as it is, which we could probably did the same by using the scatter from here. I'm going to cache this out as well. File cache. And I'm going to leave the attributes just in case I might need them. So let's call this forest source. Forest source. Okay, save current frame. Remove the $F. And load. Okay, let's put on null. For out forest PTC points. Okay. Let's go up. Let's create a new geometry node called vegetation. Oh. Let's name it vegetation. Let's go inside. Let's bring in our force points. Okay. Now we're going to create our tree system. So in here we're going to drop an L system. there's one more thing we need to do. So because this guy scattered points and doesn't care about this mask, the way the so we're gonna have trees where we shouldn't have trees. So how do we deal with this? Possibly a few ways. Like everything else in Houdini, there are many ways to get things done. One of them could be doing an attribute transfer, but you know what? I want to close this geometry, see what it does. It's going to be a polyfill. It might take a few seconds. So anything? No. Okay. Let's wait a little bit. So we will convert this object to a volume with VDB from polygons, and then we're going to do a volume sampling to select and remove those points, which eventually would end up being trees growing inside the structure. And the reason that I'm going to do this with an attribute wrangle, the volume sample, is actually, in my opinion, that is that is the fastest option. It's probably a good practice anyway. Okay, so oh, wow, this actually did better than I thought it would. Okay, let's call it. Okay, let's say VDB from polygons. Let's change this to something high because this scene scale is quite high. Let's make it density. Okay, that went through. No crashes. Okay, that's too big maybe. Okay, let's go on. Alright, that will do. Okay, let's call it out settlement volume, but we want to visualize this, so let's go in back to vegetation. Let's copy paste this guy and let's bring in the volume. Okay, let's bring in an attribute wrangle in forest. In objects, object volumes. Okay, and this goes in here. Now how do we do that? We can say float in equals volume sample. First input volume 0 at position. Okay, it's gonna create as a value 0 to 1. And now if we say, let's see if it's working. So we can see it in here actually. That's why I like my spreadsheet open, because well, we can't see it here now. We need to, because we're not exporting it. But if we do like this, now we can see it. Okay. So let's go back, because we don't need it. It's a one-time operation, we don't need it, so I'm not going to export it. And now we can type if in is not equal to 0, then remove point on itself. These points should disappear, and so they did. Okay, cool. So let's say intersection cleanup. Okay. So we have this system here, which I already did previously, so I have some working numbers. So it's 10 generations, a little bit randomness. Okay, so we can get different shapes, and step size 15. I think that should suffice. Yeah, okay. Obviously this is not a tree we could use in a movie, but Ideally, this part you wouldn't have to do. You would receive it from assets all looked at and everything, ready for you to instance. Okay, so let's put a poly wire because this is just a curve. And obviously this is not going to work either. So we are going to turn on point attributes on the L system, which is going to give us some attributes like age, etc., so which we can use. So I'm going to drop in a WOP here, and let's call this WOP branch age. Branch age. Let's go inside. Let's bring in the attribute called LAge in here, and our maximum value, our size is not going to change much, so I'm going to leave that to it is. It's not going to make a big difference. Let's put a fit 0 to 2 to 0 to 1, okay? And then if we turn back to visibility to branch age, then we can hook that up to the CD. We can see our age visualized, okay? And then I want to be able to ramp this, remap it basically, and that's a spline, remap age, and then I want to export this attribute as something called radius. Okay. Now what I can do in the polywire is that I can just type here add radius, and it all went crazy because we need to change the shape of this, and this and is actually where the tree is old, so maybe something like that. Okay, so we have ourselves a tree. Let's do the cleanup. I'm cleaning up because I have only 32 gig RAM, and I guess if I had UVs, obviously I wouldn't have deleted them. Okay, and then that's 7,580 polygons. Okay, and imagine we had the leaves and everything. That would work very well for far assets, of course. And I'm going to pack this tree. Okay, and then I'm going to write this out on disk. But before I do that, I'm going to set my seed to $F. This way, every frame it's going to give me a different tree shape. And then what I'm going to do is that I'm going to write this out on disk from 0 to 50 with the proper name. Let's call it trees. I think I do have the folder already, but I'm going to recreate it. I have many folders. Let's do a little cleanup before it gets messy. Okay. All cleaned up. Good. Okay. So I'm just gonna call it tree library slash $f.pgo.sc, and I'm gonna write this to disk. So it's gonna write out 51 different trees basically. As you can see, fairly small in size. So now how do we make use of this? Okay, we have our tree here, and we have our forest. As you guys can see, these three, we have to figure out the size, and based on the scale, it always helps to put a little human character somewhere with a real scale. But what we're gonna do now is that we need a few attributes for this to work. So we can drop in an attribute expression node here, and let's use scale. And let's have a scale, offset it around 2. I think that's my values. Yeah, okay. But this doesn't actually give me enough random, so I'm just going to drop in a wrangle. Okay, so let's say at p scale equals, let's fit this because random is going to give us a value between 0 to 1, and then we want to fit that back to another value, 0 to 1, and my initial sizes that work was 1.5 to 3. Yeah, and this should give me yep, okay, p scale between 1.5 to 3. And then I'm going to also, actually, I'm going to do this id and ptnum. And okay, this doesn't matter anyway, but let's have the id anyway. Okay, and I'm going to create this normal here, so my trees are looking up the first time I create them. It's not really important, we can change this later on. Okay, this is random scale. And now let's put another wrangle. Well, actually we can also put it in here. Let's make another one so we can keep it clear. So how do I call the objects that I just wrote on the disk? Let's call this instancing. So I'm going to create a random number again. I'm going to create actually an attribute called object ID. Object ID equals to an integer that fits between, that is created by a random number using ID okay, and 0 to 50. We are missing something. Okay. And now I'm going to create a string called instance file. And I'm going to use an expression called sprintf. This will allow me to change the portions of the script with attributes. So I'm going to go get this path, paste it in here, close it. So instead of $f, I want the ID to load the tree numbers, because by using the, I want the object ID to create the string instead of the current frame number. So what we need is, then I'm going to put a percentage sign s here, get out of the brackets, and then tell regex that I want to use, I want it to replace the string with this attribute. So if I go here now, if I expand that, that's what you'll see. Okay, and I have my files in there. Now what we can do is that basically this is what we should be rendering. Instanced points, and create a shopnet. Inside shopnet, create a point instance procedural, and now when you go outside to vegetation, go to geometry, and under the procedural shader, select this node which we created. On the vegetation, on the ShopNet, select it. Okay. And now if the path is correct, this should be working. And the way we can check this is that we can put up an instance sort, change the name here, attribute name, to instance file, and we should have our trees. Oh, there you go. And this comes with the new option of Houdini 16.5, automatically replacing instances with boxes, which is pretty cool. And we have ourselves a forest. It's a bit too dense, I suppose, but yes, it's very dense. This is not for any. This will make a forest. So I guess we can go less points, but we're just going to leave it as it is now, because that's not the goal. So now what we can do is that. Okay, this, I don't know how to turn off this new feature, so I'm just going to turn this guy off. Okay, and let's go back to visualize our terrain as well. And we can go and create two materials, which I have created here already. So it's a classic shader, it's the old one. It's for simple representation reasons. When it's now called trees. And the other things I changed is the diffuse color to something green, reflection base amount 0.6 to intensity 0.25. That's it. And then I have another classic shader that's a ground, that's named as ground. It has some noise. Make sure you turn off true displacements. This is just to create a noise on the field, like a bump map. And then surface 0.25 amount 0.06. Let's assign these. Okay, so we want, this is for the ground and vegetation. This is for the trees. Okay, and now we're gonna create an environment light, call it HDRI, and I'm gonna create a sun. Sun, and there are some numbers I'd like you to enter. So for sun, on the rotation, transformation doesn't matter. 64, 126. Okay, that should do the trick. And for HDRI, you can turn on clip to positive Y hemisphere. We don't need to see it in the viewport. It's a big HDRI, which you will find under your text folder sky.rat. And now if you create a camera from here, that's not where I create. Oh, there's a camera already. Okay, let's get rid of that. That's strange. Okay. Well, let's create the camera. Let's go to render view. And let's hit render. And we should have ourselves a green forest. Oh, sorry, we will not have ourselves a green forest. Let's render this because the flag is off, but I'll turn it back on now. But the noise map is working. Okay. So let's focus on this part maybe. Or maybe here, let me see. I'm just trying to get some nice color variation somewhere so we can see a nice area. Okay. And now I'm going to turn the progressive off and turn on my trees. And voila. Okay. So now ideally you would have to scatter these trees in a bit more smart way, based on their size. Maybe they don't overlap so much, just so it works better, not as much possibly. But that's like the most basic way of generating a forest scene that renders as fast as it can with Mantra. And Redshift would do some of the work here, I suppose. Okay, so now our trees are working. We are going to continue with animating our ship and creating our cameras so we can break things apart. Thank you for watching.